Right. First of all, Gerard, I'd like to welcome you and thank you for coming. I realise that you've possibly put yourself at some risk by agreeing to do this interview. We're going to refer to you as Gerard Latroupe. So the first question I'd like to ask you is, could you say something about your background and experiences working in the French perfume houses?
Well, like a lot of French families, I grew up in Paris, but the family has a country house in the south near Grasse, and we'd spend the summers there. And we used to go and visit the museums and the perfume shops, and it was just, I didn't imagine as a child that I'd become a chemist, but I got more and more interested in the perfume, and my uncle worked for one of the big companies, so then I ended up working for that same company. Most people stay with the same company because they don't like you to leave, because they have a lot of chemicals that they call captives, which is their only company that they have them. So you can leave, but it's pretty difficult. And during the aromatherapy explosion, lots of guys left to set up trading companies because their knowledge of the oils was very extensive, whereas the aromatherapists were just interested in the therapeutic side of oils, and they didn't understand because they weren't taught about the oils themselves. Basically, some of these guys had quite a lot of knowledge that they'd worked in the houses. And, some of the secrets, for example, one company that I worked for, they had almost like a cellar where they had large, huge, I think in English it's like demijohn, really big, and they have in there alcohol and rose, and they age it. Sometimes they age this for some years, and there's no other way that you can get that quality. And that aging is really important, but this is something that they won't talk about because they don't want other people to use their techniques.
Could you please explain how a gas liquid chromatography machine works and how you would use the information it gives to produce oils that imitate naturals at much lower prices?
A GLC machine is basically, it's quite an advanced piece of equipment, but what it does is basically very simple. It analyzes volatile materials and presents the information in terms of either a percentage of the total. So how it works is, if you imagine a very long tube, like 30 meters long, and at one end you introduce a sample of oil, and there's warm air is blowing down this tube. Now, natural molecules are very complex, and some constituents in an oil will be more volatile than others. That means that they're a lighter molecule and that their boiling point is lower than heavy molecules. So as this hot air is being blown down the tube, the lightest molecules, they evaporate first and they start moving down the tube. And then the next lightest and so on until you got the very heavy guys at the end. So because this tube is 30 meters long, while this hot air is blowing, there's enough time for each constituent, the molecules, they group themselves together. So obviously it's 30 meters long, but it's coiled, okay? So what comes out of the end of the tube is each group of molecules. So the machine is able to measure, and it measures two things. One is the time it takes for the molecule to travel to the end of the tube, and also the volume or the percentage of those constituents in that oil sample. And so a lot of the constituents in something like rose, they don't even have names. There's possibly as many as 200 constituents in rose. And so the main ones are given names, and they're referred to in like the coordinates of a graph. You talk about the retention time. So after the machine has been running a certain amount of time, you expect to see a particular group of molecules coming out. And the percentage of those molecules are indicative of the quality of the oil. So for example, in a simple oil like eucalyptus, it can be 98% cineol. So it's a very simple graph. But in the case of rose oil, it's highly complicated, and it's one of the reasons why you cannot properly imitate jasmine or rose. Now, to make it visual, I've brought some traces here, which I can show you. And this is basically the form. This is the trace that the machine makes, okay? So you can see down here is the retention time, and along here, these are called peaks, okay? And the larger the peak, the more a specific constituent. And you can see here that the chemist has written the names of these constituents. So you can see there's lots of them, and they're actually quite complicated, okay? So that information can also be presented in the form of a table, like so. So of course, you need to be a trained chemist to read this and to understand it. But in terms of quality, what I show you, this here is an official Bulgarian document, okay? It's analysis of Rosa damascena, which is Rose Otto, okay? The current harvest in both Turkey and Bulgaria is down. The weather was too hot, and when it's too hot, the little nascent rosebuds, they dry up and they don't release so much oil, okay? So prices of Rose Otto is going to go up, and the more expensive an oil goes, the higher the temptation is to find cheaper alternatives. But I want to draw your attention here to this constituent, phenyl ethyl alcohol. Now, according to this Bulgarian analysis, there's 62, just over 62%